Let's talk about 11.1, number 63, which says something about the amount of something left after something is something. When you just read that.
So if 100 milligrams is present initially, the amount present after T years is given by that. Approximate to the nearest tenth of a milligram, the amount left after 10 years.
Okay, so they're saying that this function, right, is an amount function. It outputs amounts, and our input is T years. You guys see that? So, they wanted me to figure out what happens in 10 years, right? So they want the amount after 10.
Right.
So what's the amount after 10? What do I do with the 10? You plug it in for the T over there. So I got 100 e to the minus 0.0248 times 10. Which just moves the decimal point over. So I've got 100 e to the minus 0.248. Okay. And now where do I get a number out of this thing? Yeah, this is a calculator thing. What's up?
I'm
The E?
confused on what E is.
Good question. What the hell is that E thing?
Like, are we trying to find E?
Yeah, is it a variable? Basically?
Or is it like the unit of measurement, because we're talking about nuclear stuff?
So, E's a number, a lot like pi.
I
So,
remember E.
It's one of these kind of funky numbers that has a lot of bearing on life. There's a calculus reason why this number is the right one.
It's just important enough to have a letter.
Yeah, this is Euler's constant. We named it after him, and we gave it the first letter of his name because it was that important. So we sunk one of our variable letters into this thing because it comes up. So for you guys, E's a number. It's like between 2 and 3. It's 2.7 some stuff, right? But this thing is kind of what governs natural growth.
Okay.
So I kind of need to know that this number governs natural growth, and that's about it. Calculus. Yeah, you won't need this in trig, but definitely in calculus. So I just want to know what e to the minus 0.248 is, right? Where do I get that?
Setting it over 1, under 1.
Okay, it's a negative exponent, so it's going to be under 1. We could bother with that, but I really just want to know what this number is, right? I'm really just going to cram this in a calculator, and most calculators, aka any half-decent calculator built after about 1930, will have an E key, right? So I'm looking for, on your TI whatever calculator, where's the E key? Yeah, on your phone calculator, you probably have to turn it sideways to get the scientific mode. And what do you want to type in? You push the E caret button,
Yeah.
and then you just type this number in.
0.248.
And then you get, so I'll get 100, and then what was your answer out of that? 0.7803. Whatever.
Oh, you were trying to find that number. I did 100.
Oh, yeah.
That.
Okay, so if you do 100 times this, what'll you get?
78.03.
So I'll get 78.03. And what does this thing mean?
It means it goes down past the amount of
That you need to, that's what's left after 10 years.
Yeah, this is the, so is left after 10 years. And I probably should put some units on this.
Milligrams.
Okay.
The units initially given were milligrams, right?
I got you.
Yeah.
You guys see that? So after 10 years, like 22% of it kind of
Went away.
went away. What does went away mean in this case?
decay.
Yeah, this is radioactive decay, so it turned into something else. Cool? Questions, things?
We gonna have anything like that on the final exam?
Yes.
Yes.
Yeah, so this is the beginning of chapter 11 where we're doing, right, this is the evaluate stage, right, where I plug 10 into this function and I get some number out. There's also a solve stage, right, which would be asking the question like, hey, given this function, right, how much is left in 70 years, right? Which is actually a relevant question for storing nuclear waste.
Would this be like the equation that they're using for that mine fire or whatever? The fire that's been inside of the mine?
I don't know.
It's like radioactive waste inside of this mine that's just been on fire.
For 50
underneath
years.
For like, yeah, 5 or 6 years. I don't know.
I have no idea. Possibly.
There was a bomb that exploded in the mine and it's been going off, and the fire's been going on for many
Is
years.
this a coal mine?
Yeah.
Yeah.
Yeah, and it's in the Midwest or
Yeah.
towards the east, I think Iowa or somewhere.
So the question that you want to ask to see if an equation like this is applicable
Yeah.
is the rate of growth proportional to the amount?
Okay.
And I think in a fire underground, the answer is probably not.
Yeah.
I think the rate of growth is probably proportional to the surface area or something. So maybe, but probably not. These kinds of equations come up anytime you can say this rate of growth is proportional to the amount, which happens when you have radioactive decay or money or population. There are lots of other examples, of course, but those are kind of the easy ones. Cooling is also another one of these. Other things?